Okay, let's start the next session. We have 4 keynote speakers. The first one, let me introduce Dave Allen. Dave is a distinguished engineer at Ericsson and a former distinguished member of technical staff at Nortel. He has been active in data communication standards for the past 16 years, has been active for over 25 years as an architect, design, engineer, and the developer of real-time systems in diverse areas of technology, ranging from process control and avionic to financial transaction processing. So his current role at Ericsson is focused on carrier infrastructure based on MPLS and Ethernet. He co-authors end-to-end architecture committee at Broadband Forum and was recently honored there as distinguished fellow. Welcome, Dave.
Okay. Thank you. Okay. I've got 2 small confessions to kick this off. The first is I'm a bit vocally challenged today. And so I'm going to be just fine if the AV guys help me out, but I'm not going to be able to talk very loud, and I'm going to be wandering around with this cup of tea in my hand. Now, the second, probably more pertinent to this talk, is that I've managed to spend over 40 years in engineering, successfully ignoring radio and broadband, or mobile broadband, at least that's until now. So what I want to talk to you about today is 5G. Now, 5G has sort of put radio in the spotlight, but the key thing here is that the overall goals of the 5G initiative go well beyond simple radio improvements. And so what I want to do is I want to walk you through what it's going to mean for radio, what the scope of the overall initiative is, and try and derive some meaning for this in terms of how it's going to impact core networks and discuss some of the technologies that are going to be involved. So to understand where we're going, perhaps a little bit of where we've been at the same time. Back in 1995 was when I made my midlife career change into telecom. At that point, I went into fixed broadband, which may not have been a good choice, but it's a bit late to change it now. But the key thing then is that absolutely nobody had a cell phone. In 2015, there were 7.4 billion cell phone connections active. That's 1 for every person on the planet. Those are just absolutely astounding numbers when you think about it, and they speak to the utility of mobile broadband. And this trend is not slowing down whatsoever. By 2020, we're projecting 9.5 billion cell phone connections. 6 billion of those are going to be smartphones, and 4 billion of those are going to be LTE enabled. Now, at the same time, we're also seeing the emergence of the Internet of Things. And that's going to drive a further 28 billion devices connected to the network. Now, when you think about this at a societal level, this is transformative. There is just absolutely huge value in communication and information being available to us all the time, everywhere we go. And this is big when you think about it. Now, to stay on this theme, we're going to see massive growth in mobile data. In 2015, the average smartphone in North America pulled roughly 4 gig a month out of the network. By 2020, we're expecting that to be somewhere around 22 gig. That's going to mean like a complete evolution of the RAN to try and satisfy that demand. We're looking at an order of magnitude growth in the next 5 years. And one of the interesting aspects of that, in the 1990s, we saw the inflection point where data traffic overtook voice traffic as kind of the dominant traffic on the network. Well, if you take a look at this chart there, you'll notice we just hit the inflection point where video is crossed over, is proceeding to dominate everything else. By 2020, when you go to dimension your network, what you're going to see is that you will dimension it for video, and just about everything else will ride in the noise. But one of the key things to making all of this happen is going to be radio spectrum, because the spectrum is going to be king. Now, about the time I started in technology was when the first personal computers were coming out. And we were moving from mainframes to sort of a desktop computing paradigm. And that's around the time the first cell phones came out, which tended to be sort of huge things that, you know, kind of like a Nautilus machine to lift up to your ear. And they didn't have a whole lot of utility. But by the 1990s with 2G, we had GSM phones, and we started to see mobile communications take off. Now, at the same time, we also saw the rise of the internet. Now, the cell phones started to catch up with the internet with 3G. The voice was still circuit-based, but they added packet services on the side. But in the meantime, that desktop computing paradigm had given way back to client-server because of the web technologies. And so we were starting to see the rise of the data center. And of course, that's been extremely commoditized now with cloud. We're discussing web scale, et cetera. And with 4G, we've gone to completely packet on the air interfaces. Now, what's interesting about this is that there's two things. First, there's a clear cadence to it in terms of the technology generations. But the second is that mobile broadband in each generation subsumes the sum of what's going on before it. And so we're going to see, I mean, we have massive disruptions going on in the industry right now. We have the concept of SDN, we have the concept of NFV, and the key thing is that for 5G, the intention is to subsume all of this. And this is going to be driving us towards the all information and communication technology network, and this is going to be a key enabler of the network society. Now, 5G is driven by use cases. We've long known that everything that can benefit from networking is ultimately going to be networked. And what 5G is about is equipping radio to step into that role. And if you look at it, it's actually, you know, your pretty standard business strategy. Radio has identified a whole lot of adjacencies it can move into with improvements in the technology, and it's going to aggressively go after this. So where today we primarily see personal communication and mobile broadband, there's a whole series of verticals that are interesting to 5G. This is like smart vehicles, process control. There was an interesting example yesterday, one of my colleagues' keynote talk. I would not have imagined wireless technology in mining, but it actually works out very well because it turns out dynamite is not really friendly to wires. So there's all kinds of examples of this, and of course we have the Internet of Things coming. Now you can look at this as sort of a kind of a build it and they will come pipe dream, but the key thing is that all of these applications are coming down the pipe. And when you think about smart vehicles and things, mobile communication is uniquely positioned to move into this space. So if you think like mobile is dominating the access conversation now, well, in the words of the immortal Randy Bachman, you ain't seen nothing yet. Now, all of these verticals that 5G wants to move into resolve themselves into sort of three key categories. The first is the massive machine-type communication. Now, this is the Internet of Things. A whole lot of devices attached to the network that in themselves do not generate a lot of bandwidth. The business case is not such that you would ever build a network out in itself to support this, but it will be quite cheerfully infill an existing network. Now, in a lot of cases, there's going to be like lightweight networks like Zigbee aggregating this stuff up. But it's also quite easy to imagine a lot of verticals, particularly smart city, where having these sensors directly connected to the mobile network is going to have an awful lot of utility. And actually, the business case would be very positive. We also have the ultra-reliable and low-latency communication. 15 years ago, the concept of brain surgery over IP, used to be kind of a cruel joke. But what we're talking about is hitting, sort of like 5 or 7 nines reliability primarily through densification, et cetera, and driving the latency down in radio such that you can get those feedback loops right down, and you can do critical process control. And of course, you've got a whole series of others that ultimately end up in the category of enhanced mobile broadband. Now, this resolves itself into a whole series of technical thrusts to equip radio to do this. Now, to give credit where credit is due, this diagram is from an ITU radio sector document where they describe their vision for 2020. And then they proceed to map these sort of three key categories into it. So, for example, for massive machine-type communication, compared to the networks today, enhancing state enhancing the connection density is of a huge importance compared to the state of things now. Network energy efficiency is less important, but it is still important. For the ultra-reliable, critical machine-type communication, latency, and in particular mobility to move into trains, to move into process control, et cetera, are all very important. And you have enhanced mobile broadband, which covers pretty much a soup to nuts territory, be it ranging from network energy efficiency, greater spectrum efficiency, higher peak data rates, et cetera. So this gives you some insight into the fact that 5G, just even in the radio space itself, resolves itself to a broad set of technical initiatives. Now, at this point, I'm assuming that anybody who actually is really, really interested in radio is down at the 5G observatory downstairs. So what I need to impress upon you is that, radio is different. And this manifests itself in sort of two key areas. The first is the behavior of the data plane, and the second is the nature of the control plane. Now, as far as the data plane is concerned, it's a line of sight interface between an antenna somewhere like on a cell tower or something and a mobile terminal. And as such, it is subject to all kinds of interesting impairments, primarily due to mobility. And so, for example, rain, buildings, buses driving by, things that interfere with the line of sight, you can see the available bandwidth go up and down by orders of magnitude in a very short time. Radio, uncorrected on-air interface, you'll see about a 1% packet loss. I don't think you could run a wireline business on that, where we're seeing like at least 10 to the minus 7 or whatever, even on long-haul optical. The other thing is the radio control plane. Now, this is kind of an artifact of the fact that it started out primarily as a voice technology and involved in person-to-person communication. But the thing was that control plane grew up to be largely integrated with the radio to make the radio work better. And so, for example, for mobile, the success formula with this control plane is the absolute antithesis of the end-to-end model that has been the success formula for the internet. And so when these two worlds meet together, it becomes an interesting exercise trying to rationalize these. Now, 5G radio is going to be different yet again. What are we going to see here? Certainly a lot more flexibility in terms of how LTE behaves to allow it to address more verticals. There's a key expectation that we're going to be pulling an awful lot more intelligence into radio access networks. Therefore, we see the emergence of the notion of the C-RAN or Cloud RAN. Probably the big thing is, and I'm going to go into this a bit more, is that it's going to be moving into higher spectrum ranges. And to be able to successfully deliver service at a higher spectrum, there's a whole lot of technologies and implications in terms of how the RAN is both designed and engineered. And that's all going to be pretty big. So to give you a sense of this, LTE actually started in about 2010. That was the beginning of 4G. Now, the interesting thing is while I've described these technologies, sort of the generations are on a decade sort of cadence, 3GPP as a standards body actually has this unbelievable pace of output. They put out a release every year, and each release has about a 3-year gestation period in terms of planning and how the work flows through it. Having been in standards for over 20 years, the pace that these guys work absolutely floors me. I have no trouble imagining some half-naked guy with a drum in the back of the room beating it, going, "Row, you bastards, row." but that's how they work. And so we're already well into incremental modifications and improvements in LTE. So we have like, probably the big one is that LTE Advanced has this thing called carrier aggregation. And this is a particular feature for carriers that are challenged to get large contiguous blocks of spectrum. And what it does is it allows a whole series of discontiguous blocks to be glued together as if they were a large block. So this is pretty cool and has great utility. Now the thing about LTE is most of this is happening in frequencies below 6 gigahertz. Now, the evolution of LTE for 5G is going to add, like I said, a whole lot more flexibility. It's going to allow carriers to use unlicensed spectrum, and this will involve sort of a handshaking, almost like the old collision detect in Ethernet, to make sure that radio towers aren't colliding. They're going to drive a lot more low latency into it. Lead design concepts was something I originally questioned, but it turns out that this actually is trying to reduce the complexity and duration of on-air signals to hang everything together. This is not software design methodology or agile. And of course, there's a whole series of extensions to make the Internet of Things work, in particular narrowband LTE, which is going to be a very low power mode. But sort of the big news is the NX spectrum. And this is not going to be backwards compatible. This is going to be sort of a new space. And it's going to extend from 6 gigahertz all the way up to 100 gigahertz. Now, this is where those pesky laws of physics get in our way. Moving from 2 gigahertz to 28 gigahertz causes a 40 dB drop in signal strength. That's 4 orders of magnitude. You can hear me now, despite my sort of rather hoarse voice, because I'm nicely amplified. If I was across the street whispering, you'd be having a few problems. Now, there's going to be 2 responses to this in the RAM. The first is there's going to be certainly an increased densification of the number of antennas in the RAN, so I'm never as far away from an antenna when I'm using sort of the ultra-fast mobile broadband. And the other is this technology called beamforming. Now, beamforming is really cool. What you do is you have an antenna array, and by slightly modulating the different signals on the antenna array, you can make the sum of the signals point. So, for example, I can point to you, do you a quick 10 gig burst. Point to you, do a quick 10 gig burst. Point to you, Michael, do a quick 10 gig burst. Now, if I was to make this analogy much more complete, I would ask the 3 of I just pointed to jump up and start running around the room while I tracked you, trying to point at you as if I was sending communication to you. So it gives you an idea of the complexity of the problem, and it's a very cool technology. But the key thing is, you know, for example, advanced radar systems have been doing this forever. It's just that technology is now moving into the cell phone space. But so far, I've really talked just about the radio improvements and some of the requirements and the motivations for 5G. But if you have a look at what 5G is trying to do, which is to move into all of these different adjacencies, then it's kind of fairly easy to see that there's going to be a pull-through of a whole lot of other technology. Simple radio improvements are not going to do this by themselves. And so, for example, shaving a millisecond off of the latency of radio handshaking is not going to help me if my application is hosted 100 milliseconds away. That's not going to meet sort of the critical requirements. So what we're discussing here is an evolutionary, but ultimately a complete re-architecting of service delivery and radio access networks to meet these new challenges. And SDN and NFV are going to be key for making this happen. Now, there's a bunch of things that haven't changed. You're probably not aware of the economics of radio. Radio spectrum is considered to be a public resource. And what that means is that governments administer it, treaties are written around it. If anybody of you were in the 5G observatory yesterday, obtaining spectrum was a big discussion item. And this is so much so, and this has such economic impact, that for a major carrier, obtaining spectrum, the cost of licensing that spectrum, starts to rival their CapEx budget. So making the most of that asset is absolutely critical. And what's more is there's a whole lot of business models that exist around carriers being able to share that spectrum. So you have the notion of a mobile virtual network operator. And all of these business models need to be carried forward into the new world. There's this huge need for backwards compatibility, and that's very simple. How many of you have a cell phone in your pocket and expect it to keep working? And of course, the need for service assurance hasn't gone away. A carrier always needs to know more what's going on in their network than their customers. But when you throw in how totally dynamic mobile is and how much more dynamic it's going to be with 5G, there's going to be a whole new set of challenges that go with this. Now, what are some of the impacts that are going to impact, well, what parts of this are going to impact transport? Probably the key thing is the greater bandwidth. We're talking at bursting 10 gig, 20 gig to individual terminals. And so what this means is much larger bandwidth in the radio access networks. There was a time when these things were stitched up with T1s. And even now, even in 2020, we're still expecting about 50% of backhaul to be with microwave. But we're also going to see, the whole multi-site, multi-antenna. One of the interesting aspects of this is that my mobile terminal will be able to be simultaneously homed on multiple towers and be receiving from multiple towers simultaneously. This whole dual connectivity. Oh my God, I've been talking way too far. Okay, so the new deployment strategies. We're going to have this thing called front haul, which we've dummied down the radio towers simply to be D to A converters and antennas, and we send them the waveform. But what that means is 10 gig of on-air requires 100 gig of front haul in the transport network. And with densification, there's a desire to mix front haul and backhaul together, which is moving it from being a WDM technology to a packet technology. And if you excuse a really bad pun, what this means is that front haul is going to be the elephant flow in the room. And of course, the core architecture elements that are pulled in, this is where we're going to see large degrees of virtualization and where the old world is going to meet the new as 5G subsumes these technologies. And what this means is we've got this changing service environment. Radio services are expected to be much more ephemeral once we've done this re-engineering of the RAN. And the net result of this is that the old mode of operation of deploying boxes, having them installed, taking weeks to turn up a service, just isn't going to cut it. What we're going to need is virtualization and a high degree of automation. This is going to drive abstractions like network slicing, a bit more of that in a moment. But the key message here is it's going to drive automation, automation, automation to make this happen. Now I mentioned network slicing. Network slicing is the new VPN. You can see a lineage from private line to VPN to the network slice when you think about it. But it's a much more interesting beast. We live in a reality defined by the laws of physics. There's a coldest temperature. There is a fastest speed. There's undoubtedly a whole bunch of other limits that we just do not necessarily know about due to the limitations of our science. Well, what a network slice is a box that a business service or business relationship or a service lives in. And so the network slice is the laws of physics that define that reality. Now it becomes very interesting because it's not just connectivity. It's compute, it is storage, it is going to be elastic, it is going to be dynamic. And the key thing is I gave you the example of a mobile virtual network operator. Those sort of business models need to be carried forward because they're part of monetizing spectrum. Now to make this all work, we're going to need a whole lot more cross-domain coordination. And what that means is that any barriers that exist between the old way of running networks, which is like configuration, management, commissioning, adding to inventory, and the modern way of working for virtualization, these are going to need to be broken down. And the old two solitudes with diff-serve as the primary coordination point needs to be, this is not going to cut it. And that brings us to a concept we call radio transport integration. Now, I was going on in the densification of the RAN. What this means is that the topology, even visible to the mobile terminal, is going to be much more rich. I'm going to see more error interfaces from my mobile terminal. There's going to be a much greater richness of backhaul. And the key thing about mobile is we can manipulate this. We can make the network work a hell of a lot better because we can actually rearrange the load. But what that means is we need network exposure and coordination between the transport and the radio domains. We have this other challenge that we're seeing increasing amounts of encryption. This is the societal response to pervasive surveillance. And what that means is traditional techniques like DPI are not going to tell us all the things we need to run our network. Well, I mentioned before that radio control plane. It actually knows a fair bit, and if it can share what it knows with the transport network, we can make them both work better. So every time I've had a long career. Every time I think I've seen it all, something steps up and surprises me. 5G is one of those things. And I hope I've helped you understand the idea that 5G is a lot more than just radio improvements. It's going to ripple across the technology food chain. And if you look at the adoption curves for mobile broadband, it actually is a sector that's going to have the muscle, the technology, and the chops to do that. But that's going to drive a whole lot of things going forward. We're going to need better abstractions. We're going to need increased network mobility. We're going to need cross-domain orchestration integration. And I've told you about network slicing as a practical example of how to monetize this. So to sort of wrap up, when I first started looking into 5G, I didn't think I was going to have much of a story to tell you. But frankly, I was astounded at what I found. So I wish you all a great conference. And I hope you find some astounding things over the next few days. Thank you very much.
5G, it's much more than radio. It's a scalability and how do we use SDN and NFV. Thank you.
Okay. Thank you very much.